This is a normal request, and this is a WebSocket loop. When you're creating a voice AI, you need WebSockets in order to solve a very specific problem that I'm going to talk about here. But first, if creating a voice AI, all you need to do is send the audio and then it gets transcripted and then you get the audio back, then why do you need WebSockets? Why can't you just do a normal request? And also, if WebSockets are just about lowering latency, then why can't we do the same thing with a normal HTTP request? Over the past few weeks, I had to study WebSockets in order to create my own voice AI model, and I needed to switch between normal request and WebSockets. And here I'm going to explain why, and it all starts with understanding the normal HTTP AI approach, and I'm going to explain what it is about. So first, let me explain what I call app here. For me, app is just like what the user sees, what usually people call like the front end, and the code is just the back end, like what people don't see, right? So what you see is what you see in your browser, basically, right? If it's a web app. I'm going to take the example of a web app just to make things simple. So the first step here is you talk to the app, right? So you basically say something and then it gets translated. That's the first step. The app is going to capture the sound and send it to the backend, to the code. Actually, even before sending the audio to the backend, you need to tell the app, well, I'm done talking now. You can send the audio to the backend. So you need to push some type of button. And then we get to step 2, which is the audio processing. Basically, the audio gets transcripted into text so that the AI can then use a large language model to process the data, right? So if I say, hi, how is it going? Then that's what's going to go into the large language model. But it needs to get transcripted before that. So transcribing the audio is done by what we call a speech-to-text, so STT. Is just a tool that is going to do that for us, right? Whatever the tool is, there are a lot of different tools to do that, but whatever we call it, we use the umbrella of the speech-to-text tool. And because I don't want to get into the details of like all of the different software that we can use in order to do that, it doesn't necessarily matter. Once we get the response from the AI or the large language model, then we just convert it into text using a text-to-speech type of tool. It's the same thing as a speech-to-text, but it's just a different tool to do that. And same thing, there are multiple tools to do that. It doesn't necessarily matter which one it is. And so the output of the code or the output of the backend is going to be audio, right? That's at the end of it, that's what we want. We want the audio of the AI that responded. And then the last step is sending the audio back to the front end. Why do we do that? Because the front end has the mic, basically. That's the only reason. Like that's what the user experiences, and so that's we cannot have access to the mic from the back end. So that's why we do that. And then the AI talks. That's pretty much the only thing that we need to know. We don't necessarily need to know what HTTP stands for. Like that's just a protocol to send the data. But that's what it matters. What matters is that there is all of those steps when we use that specific protocol. And that's how it works, right? It's pretty straightforward. There is 3 simple steps: sending the audio, processing the audio, and sending the audio back. So what's the issue with that? The problem is the first step is you need to talk and then you need to send the audio. And when you think about it, that's not really how it works in real life. Like we don't just talk and then send the audio to somebody so that that person can listen when we are talking in real time. When we are talking in real time, in the real world, people listen while we talk. And they also start processing the information while you're talking and thinking about what the answer might be, or they think about really what you're saying and trying to understand what you're talking about while listening. So this is why step 1 and also step 2, they need to kind of happen at the same time while you're talking. So really what we want is get rid of that send button in order to have the processing getting done while we are talking. And then when we're done talking as the user, what we want is just having the audio being sent, because the AI has thought about what you were saying while you were talking. And then all that needs to happen when you're done is the AI makes the decision of sending the audio to the front end so that you can hear what the AI thinks or what it's saying. So this is why latency is kind of a trap here, because that's not really the problem that we want to solve. We don't care about things going faster and not waiting for the answer. This is not the issue. So what's the issue here? It's that send button. We want to get rid of that button. We don't want to send the audio. We want the AI hear the code making that decision from the backend. And so obviously the backend cannot make the decision that you're done talking if it needs to wait for the user to push a button for it. So that's why we need to get rid of that send button so that we can talk to the AI directly and the AI can respond without us having to do anything, right? This is a real world experience of talking to an AI. That's what it should look like. So why do WebSockets solve that problem? How do they do that? So what WebSockets are going to allow is send bits of audio at a time. So basically every 200 milliseconds, for example, we're going to send audio data while the user is talking. So it's only going to be a few words at a time. So the same thing is going to happen where we transcribe the few words at a time and then we reconstruct the sentence while the person is talking. And that's when we can actually make the decision, when the user's turn has ended and we are done with listening to the user, and now it's our turn to talk. So the text gets converted to audio and then we just send the data right away. So as you can see here, nothing is in there. So here are the key takeaways of this video, just to make it simpler. So in short, the problem that the WebSockets are helping us solve is that they kill the send button, they help us stream audio continuously, and they help us make the backend take the decision on turn taking, meaning that when it's the AI turns to talk and it doesn't need any user data being sent, meaning like using the send button in order to do that, it can take the decision on its own. Now, if you do want to create your own AI by yourself, I know that it can be very tough and it can be time consuming and risky to do that on your own. So I created a free online course that you can download by just clicking on the link in the description. Thank you for watching and see you in the next one.